Hello all, I hope everyone is doing good. I thank the organizers of the 4th International Conference on Electrical and Electronics Engineering for providing me the opportunity to present our work here. I am G. Nithin Reddy and I'll be presenting on the topic of transmission of Wi-Fi signals on 11 kV power transmission lines, a laboratory study. Our paper ID is 8054. Moving into the presentation, I'll be introducing about the work, the motivation to work on this field, the existing technology, and further brief introduction about the surface transmission of Wi-Fi signals on power lines. For that, we require a launcher technology, which I'll be discussing further. And then I'll go through the experimental investigations, and then I'll be discussing the results of the preliminary work. Finally, I'll be concluding my presentation. So we all know that with the rapid advancement of digitization, the demand for data and connectivity has seen an exponential growth. However, despite the phenomenal growth of the digital infrastructure, a significant disparity persists between the urban and rural areas regarding internet access. Even today, the rural parts of the country suffer from poor or non existent internet connectivity. One of the primary reasons for this disparity is the lack of viability for service providers due to low average revenue per user ARPU in rural areas. While fiber connections have been established in a substantial number of these panchayats, the end users residing in the surrounding villages, typically around 3 to 5 kilometers away, remain unconnected. In response to this challenge, the government of India has taken proactive steps to address the issue. They have developed a strategy that focuses on laying fiber connections in a significant number of gram panchayats. While this initiative helps to solve some of the administrative aspects, it still leaves the end users, especially in the surrounding villages, without access to reliable internet connectivity. Despite the remaining challenges, the government's efforts demonstrate a commitment to bridge the divide between these rural areas. Further measures and innovative solutions are required to extend the reach of internet services beyond the Gram Panchayat, especially, and ensure that the surrounding villages can also benefit from the advantages of digital connectivity. For this, the solution needs to be cost effective, resilient, and easily implementable. In order to address this challenge, the existing infrastructure of power lines can be leveraged to transmit the internet traffic from the Gram Panchayats to surrounding villages, which is known as wireless over wire technology. So the pictorial architecture is shown here, where the Gram Panchayat is connected through an Ethernet cable, either with a fiber connection. Uh, then it is connected to the nearby villages through this wireless over wire technology, which is the WOW solution, whichever is the abbreviation. And then it is connected to the nearby villages through the wireless connection, which comes from the WOW architecture. This WOW solution consists of the transmission lines, which serve as the waveguides at the fundamental level. The conductor's surface wave propagation is made possible by a launcher, which transforms these radio impulses into transverse electromagnetic waves, which are known as TEM waves. So a single launcher is not sufficient to transmit the transverse electromagnetic waves on the transmission lines, which is shown here, due to the bends or different tappings and other discontinuities, which lower this link performances of the transmission lines. So in order to counteract these losses, a repeater may be used in the path to transfer the transverse waves for longer distances, like some kilometers or such. So this repeater ensures the desired performance through proper amplification of the signals which are lost during this transmission. So the theoretical and experimental work on surface wave propagation over single conductor transmission line has been extensively reported by many of the researchers. One such is Gaubau introduced a single conductor surface wave transmission line to line having a dielectric coated conductor. In his work, he introduced the conductivity and dielectric losses in the line as a function of thickness of the dielectric layer and dependence of surface wave frequencies on the losses. Next, Akelin discussed the use of single wire transmission lines for high frequency applications in terahertz range. Traditionally, transmission lines are typically designed with multiple conductors, but here Akelin focused on the unique properties and advantages of single wire configurations in terahertz frequency range. He explained the design considerations and techniques for implementing efficient single wire transmission lines at those frequencies. The impact of different factors such as wire diameter, dielectric materials, and impedance matching on the performance of the transmission lines have also been explored by him. Then Elmore provided an overview of the propagating wave phenomena on a single conductor transmission line, especially discussing about the attenuation in surface wave transmission. In the case of an unshielded single conductor transmission line, the surface wave fields originating from the wire axis spread out and experience attenuation in the transverse direction. And additionally, the wave also undergoes attenuation in the longitudinal direction due to several factors, including the finite resistivity of the wire as well as the dielectric process and leakage in the surrounding medium. So these were the topics which have been discussed by Elmore. And apart from these, challenges such as environmental influences rain, fog, dust, and all, signal interference, and the need for calibration and maintenance of surface wave sensor technologies have to be studied further. So, in order to establish the transverse electromagnetic waves on the power transmission lines, we require a launcher. The launcher efficiently converts the radio frequency signals into transverse electromagnetic waves. For this, the launcher should meet certain design criteria, such as it should have efficient TEM signal generation, so that adequate transmission is ensured along the power line. It should even have proper electrical stress endurance, because the launcher must be capable of withstanding the high voltage, high current, voltage surges, current surges, and other electrical stresses which are commonly encountered on the power lines. It should be weather resistance, because it should operate reliably under various weather conditions like other environmental factors like temperature, humidity, and precipitations. And the mechanical requirements, it should be strong enough to enable its installation on the power line is very strong, and it has a secure attachment. It should be designed to withstand the vibrations, wind loads, and other mechanical stresses which may be present in the installation environment. And the installation also should be quick and easier, so that it is available, and the mounting also is efficient, so that there are minimal power disruptions during the installations. It involves considering factors such as ease of access, simplicity of mounting mechanisms, and all, streamlined installation procedures and all. So in our work, we have mainly focused on the electrical and environmental parameters such as moisture, because under moist conditions, water droplets accumulate on the conductor, changing the dielectric nature of the transmitting medium. So the valve configuration consists of a transmitter launcher and a receiver launcher on an aluminium rabbit type conductor evaluated for 11 kV AC at the high voltage laboratory at Indian Institute of Science. So the supply for these routers are provided from a 12.8 volt 72 amp hour battery. The transmitter and receiver launchers are connected to a transmitting and receiver routers. And the Wi-Fi signal strength from the routers is observed wirelessly with the help of a laptop. The entire setup is placed in a 5 cross 5 cross 5 meter rain fog chamber and energized with a 11 kV connection AC source. This connection is given from the high voltage transformer of rating 150 kV, 300 kVA, and a regulator unit. This entire image is shown for the entire setup under dry conditions. The same setup is energized for 11 kV AC with the same AC source. Here in the wet condition, the IEEE standard fog nozzles are operated, this one and this one, by allowing the water with conductivity of around 440 microsiemens per centimeter and compressed air. So when both are mixed together, we get a fog around this entire setup. To support this entire conductor as well as the launchers, we connected it with an insulation support in between. We can see the typical data signal received through the receiving router, which has been received wirelessly in the laptop through the receiving routers and all. One such typical data signal is shown here, where you have the maximum throughput, the average throughput, as well as the current throughput. The entire cycle of this data received is of 10 minutes, and sorry, it's around 7 minutes. And we have checked the data at different conditions. One at a dry condition without 11 kV, and the same condition of dry with 11 kV, and without 11 kV under moist conditions, and with 11 kV under moist conditions. Here we found an interesting result where when an electric stress of 11 kV is applied, we have seen an increased average current throughput, and Under moist conditions, the throughput of average current has also increased further. This is due to the change in the dielectric properties surrounding the launcher as well as the conductor. So these were the results which we have observed through our configuration, which we have tested for both dry and as well as moist conditions. So concluding our presentation, we have discussed about how to utilize the power lines as a medium for transmitting the Wi-Fi signals, which can be used for transmitting the internet from the gram panchayats to further deeper villages. In this case, a specialized launcher has been designed and subjected to extensive testing in various field conditions, in dry as well as wet conditions with electric stress as well, to ensure its reliability and performance in real world scenarios. Here, in this case, further work is also in progress on evaluating the developed launchers for better insulation withstand capabilities. Thank you.